So for density, the important thing here is the fact that density is a measure of how much, let's just say, mass there is in a certain amount of space. And so for this, there are two big units that we use for density. The first one is grams per milliliter, and the other one is grams per centimeter cubed. Now, generally, we use grams per milliliter for liquids because liquids are measured in milliliters or liters, and grams per centimeter cubed is usually used for solids. And that's just because when you're talking about solids, solids have to be measured in some way that gives you like a length times width times height. And so our first question here is which one is more dense? And so under example 1, when you guys are looking at it, we have two boxes. Each box is the same size, but box 2 has more dots in it. And so we can assume that there's more stuff in here. So this would be something that we could say is more dense. Then under example 2, we see that both boxes are different sizes, but they have the same amount of stuff within it. So in terms of which one is more dense, in this case, it's our first box because there's the same amount of stuff, but it takes up less space. And so this idea of density is an important one because we can use density to do a whole lot of different things, such as we can identify different solid substances, we can determine what a liquid is, and in some other cases, this also explains just how certain things interact. So one example would be if you have a really dense liquid and a really not dense liquid, like let's just say salt water versus alcohol, like isopropyl alcohol or rubbing alcohol. If you mix these two together in, let's just say, a glass, yes, they're both clear liquids, so you wouldn't be able to see, but these two liquids would actually separate, and the isopropyl alcohol being less dense would be on the top, and a more dense liquid, like the salt water, would be on the bottom. You can actually see this if you wanted to try this yourself with if you find a small dish, if you put a little bit of honey in the bottom of the dish and then put a little bit of water on top. You'll see that the honey won't just kind of mix in with the water. You'll end up with separate layers as a water layer and a honey layer. And so let's kind of talk a little bit more about density because this is actually one of the first things that we do a lot of math with. And so our equation for density is equal to the mass of an object or substance divided by the volume of that substance. So if you think back to our two main units of density, grams per milliliter and grams per centimeter cubed, grams is a measure of mass, milliliters and centimeters cubes are both measures of volume. And so generally, when we write out our equation, we write it as D, standing for density, is equal to M over V as mass over volume. And so let's look at solving a couple problems with this idea. And so our first example here says, what is the density of an object with a mass of 125 grams and a volume of 28 milliliters? So first up, our equation, D is equal to M over V, or mass over volume. So now as we're reading this, it says a mass of 125 grams, so that represents our mass, and a volume of 28 milliliters, so that represents our volume. And so if our equation is mass divided by volume, when we plug this in, it would just be 125 grams plugged in place of our M and 28 milliliters plugged in place of our V. And so we have 125 divided by 28, which when we plug this in is going to give us 4.46 grams per milliliter. All right, not so bad, right? So our next example says, what is the volume of an object with a density of 2.34 grams per milliliter and a mass of 343 grams? So let's kind of think about this then. So density is equal to mass over volume. Now this time it says we're given a density of 2.34 and a mass of 343. So now when we plug these numbers in, we have 2.34 is equal to 343 divided by our volume. Now, anytime you have a number that's on the bottom of a fraction, like 343 over v, you should always multiply both sides by what's on the bottom of that fraction. So multiply both sides by v, instead of trying to move the 343 to the other side. Now, by doing that, our v's cancel on the right side, and that leaves us with v times 2.34 is equal to 343. Now from here, if we have v times 2.34, we know we can divide both sides by the 2.34 to solve for our volume. And then our 2.34s cancel, leaving us with our volume is equal to 343 divided by 2.34, which in this case gives us 147 milliliters. Don't forget your units as you're plugging these in or when you're writing out your final answer. And finally, our last example for this video, we have a cube with sides 4 centimeters in length has a density of 4.2 grams per centimeters cubed. What is its mass? Now for this, what it's telling us is we have 4 centimeters, a cube with 4 centimeters. Now it didn't give us a volume, but it did give us a density. So in order to solve for mass, our first step should be to take these 4 centimeters in length, and since it's a cube, that means all the sides are the same, and we should solve for the volume. Now, remember our generic volume equation is length times width times height. And so this should be our first step. So it's our volume should be 4 centimeters times 4 centimeters times 4 centimeters. And so 4 times 4 times 4 is 64. So we have 64 centimeters. Now, if we take centimeters times centimeters times centimeters, that means we now have centimeters cubed. And that's good because remember, our density units should be grams per centimeter cubed for this example. And so now that we have a volume, we have a density, we can now plug it in to solve for the mass. So remember, density is mass over volume. And if we plug in what we know, we have 4.2 is equal to our unknown mass divided by 64. Now, just like in our previous example, anytime we have something that we're solving for within this fraction, we multiply both sides by what's on the bottom. And so in this case, we're going to multiply both sides by our 64. And so that means that our 64s cancel out on the right side, and our mass ends up being equal to 64 times 4.2, which, when we plug it into our calculator, we should get a mass of 269 grams. All right, so that's it for density.